Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today our tutorial will cover on friction, dry friction to be exact. And in this chapter, in our syllabus it is in chapter 8, and as such it actually have the possibility that it may combine all what we have learned before, right? So the understanding of moment, for example, etc. Right? So just be sure to understand that the question that will come up in the final can actually incorporate multiple chapters, depending on your luck perhaps, or what will be the decision of the examiner or the lecturer. Right? Now, the nature of the question for this chapter can vary a lot, right? Because the nature of friction in our reality actually is diverse, right? It can be of the simplest form until the most complex form, right? So for example, the simplest type of question can be like this. For example, a box on a surface, on a flat surface, and then we have a force, and then we know for sure it is impending motion, right? The first one is we know it is impending motion, sorry, right? So for example, the question says, what is the minimum force to move this object? Meaning that what is the force where it just reach impending motion, right? Or what is the maximum force not to move, right? What is the maximum force that you can push without moving? So that is the maximum point, right? So we know, okay, the question is about impending motion, for example, right? Especially when it is mentioning impending motion, right? But when you say minimum or maximum, it is about that just before it moves, right? So that's the simplest one. But the question can be unknown, right? For example, we know the force is a certain value or something, right? It can be it already reached the maximum friction that the surface can provide. Or it can be below that, before that, meaning that the friction to counter this force is not yet maximum. It can go higher, for example, right? So in that case, do not assume it is impending, right? So if you have done, or if you have gone through the lecture, you should understand this point already, right? Because when it doesn't have any force, it doesn't have any friction. When we apply certain force, when we apply certain force, certain friction counter, right? When we increase the force, the friction will increase as such to counter the movement until the point that the friction is already maximum because of the surface, right? Rougher surface, maximum is higher, right? When it's very slippery, the maximum is very low actually, right? So it depends on the type of surface, hence the coefficient, right? So we should not, if you do not know it is impending, do not assume it is impending, right? It might not. It might be below the maximum friction, right? And then, even if we know it is impending, right? But we do not know is it tip or slip, right? For example, like this. Okay, I don't have any surface that is flat enough, right? But anyway, so when I have force here, even if I know it is impending motion, it's just about to move, I do not know yet, is it just about to move like this, or is it about to move like this? Meaning, is it slip or tip, right? So there's two possibilities there, right? So you have question that test your understanding how to test whether it is about to slip or about to tip, right? So that's one. And then you might not even know is it impending, right? So there's three possibilities there, okay? I do not know whether it is yet, meaning the friction is well below the maximum friction, or it's already reached a certain point where it is about to tip, or it already reached this point where it is about to slip, right? So there's three possibilities there. Or things can get more interesting if it's something like this, right? So many possibilities can happen, right? So tipping and slipping is one thing. If the force is upwards, right? So if the force is pushing upwards, right? It depends on how the question is worded, right? So if the tendency of box is due to this force is quite big, it is about to move up, then friction is countering like this. But if this box is quite heavy and it's about to be dragging down, dragging itself down basically, but you have a force here, but the force is relatively small, just to prevent it from going down, the tendency is still going down, so the friction is going up, right? So you have to understand what's the scenario, right? So when you have slope, and the question can be more tricky when the question actually asks for the slope, right? At what slope, etc., right? So because when you have the slope, you have to consider also many different scenarios that can happen, right? So the issue of moment can come there. And then this one is related. If you understand the concept, you should understand this one. But because some of you might not able to visualize this, right? Tipping and slipping, actually the visualization is, for example, on a flat surface, right? The normal is at the middle. It counter the weight, normal, right? But when you apply a force to make it, we covered this in the lecture, right? Hopefully you still remember. When you apply a force, the whole thing have to counter both to prevent the movement as well as the rotation, right? So when this applied here, the normal actually move in this direction basically, right? This is to simplify, right? Actually it's not like one point and it's moving, right? We have covered distributed loading, so actually it's distributed. But when the distribution may be flat, if you can imagine the arrow and flat, and then when you have force here, it becomes like a triangle, for example, right? So the resultant is shifting here, right? So because if shifting here, it actually produce moment that way to counter this moment this way, right? So hence it stay stationary. So the moment is going here, the force is going here until the maximum. It can no longer go that way. Hence, at that point, it will topple, right? So that's the concept. So if you understand that, you can understand if you have two contact points. For example, sometimes in the question you have car with wheels, right? So there's two wheels, right? Or maybe even yourself, you have two legs. So there's only two contact points. So the force is not moving like that. So it's basically two normal force on your leg, right? Two normal force. I cannot show my leg there. So you can imagine two force upwards. If you are stable, it's the same, roughly, right? You can feel your leg same. But if you have someone pushing you in this direction, and you are, meaning you are stabilizing yourself, you will feel which one of the normal force is heavier and heavier, right? Because your weight is shifting that way, and the normal force here will become bigger to counter it back, until the point that this one is zero. You are about to tip, right? It's zero already, right? All normal force is there, right? So you can imagine the scenario, right? Hopefully you can imagine, try to have your friends push, and until the point that, because you will feel your leg over this side will be heavier and heavier on the floor, means the normal force there is bigger and bigger until this foot becomes it feel lighter until it's about to lift already, right? At that point you are about to tip over, right? So that applies to cars, etc., where in the diagram it's like there is only two contact points, right? So basically from there it's the same concept as the triangle, etc., right? So the resultant normal force is shifting from middle until there, right? So those are all different kind of possibilities. I'm telling this up front because there are possibility that the question in your exam, for example, in a scenario where it is a take-home exam. So normally the lecturer have the tendency to make the question to become more complex, because you can have certain reference. Perhaps you have the resources to do that. So the question, if the question is open book take-home exam, for example, right? So normally the question will really test you on the conceptual understanding before you can even apply any equation, right? So I'm telling you this so that you understand. When we cover all the question, do not memorize. Do not memorize. Make sure you understand why exactly are we using that equation. Why are we not using that equation? Why is the free body diagram is like that or like that, etc., right? Why is the consideration this or that, etc., right? So Yeah, so that's just a reminder for you to really try to grasp the understanding behind whatever calculation that we will have, right? Because some of the question that we will cover from the previous exams is quite straightforward. From the student perspective, it's quite straightforward because you just apply equation. However, the same diagram, you can rephrase the question and the question becomes totally complex. You have to understand, wait, what is the circumstances now, what is the possibilities, and hence equation of free body diagram can be multiple possibilities, etc., etc., etc. Alright, so with that said, for all the questions that we will be covering on this tutorial session, the PDF is in the description box below. As usual, you can just take a look and see which question that you want to cover from this tutorial, inshallah. And without further ado, let's go to the first question. So this is the first question. So you have the rod AB there as shown in the diagram, and then the question says, part A, determine the minimum force P necessary to prevent the 20 kg rod AB in the figure from sliding. The contact surface at B is smooth, whereas the coefficient of static friction between the rod and the wall at A is μs equal to 0.25. And part B, if the contact surface B is not smooth, will the minimum force P necessary be higher or lower, and why? Alright, so this is where this question is pretty simple, as we will see after this. However, the basic understanding before you start to even draw the free body diagram and answer is crucial, because if you start off with a wrong understanding of the question and of the scenario, the whole thing will be wrong, right? So it happened a lot in the exam, things like this, right? So make sure you understand, right? So we will draw the free body diagram first. It's quite straightforward. You have the rod there, so you have the rod here, right? Okay, this part is quite straightforward. And then the angle is 3, 4, 5, right? And then obviously you'll have here the force is given as P. This is point B. This is point A, right? Right. So another thing that should be obvious is that at the contact point there should be normal force. So we can see this is normal B and normal A, right? So contact surface support is obviously normal force. However, the question is, where is the friction and which direction? Where is the friction? Of course, the question states contact, this surface is smooth, meaning no friction, while this surface have friction, mu Sn. So you have here you have mu S equal to 0.25 for the what? For the wall, right? But that does not necessarily mean that the friction here is mu Sn. Why? Because we said that mu Sn is the maximum friction force, meaning that when it reach the impending motion, that is when friction equal to mu Sn, right? Make sure you understand that. So what the question says? The question says, what is the minimum force P? What is the minimum force P necessary to prevent from sliding? What does that mean? Meaning that this, especially when this is smooth, right? This have a tendency to fall down, right? So it have a tendency to fall down. So to prevent it from sliding down, what is the minimum force P? What does it mean? Because minimum mean anything less than that is not sufficient. But anything more than that, that's more than enough, right? So that's the minimum. Meaning that the friction here reach the maximum. You understand? Because let's say it is about to slide, so the friction will counter. That friction is not enough. Will all still slide, friction increase until it reach the maximum. It cannot counter yet anymore, right? So the only thing that can counter from movement is this force P. So that's the minimum force to prevent from sliding. Now, if the force is more than that, it can still counter without this reaching the maximum, right? So that is where the understanding can, okay, the minimum force here is when this already reached maximum, right? Alright. So, what is the direction of friction? If you understand the scenario, it is about to slide down, then the movement at this point is going down, so the friction counter it by going up. So F equal to mu Sn, so 0.25 normal A, there. That's the normal of the contact point itself. So there you go, that is the free body diagram, right? And the angle is, the triangle is 3, 4, 5. That's the angle. Right. What else do we know? Okay. The question also mentioned about the weight. So it's basically given the mass. So at the middle here, we should have, because it says 20 kilograms, so 20 times 9.81 Newton. Okay. So that is all the information that we have. Just to check, how many unknown do we have? So we have 1, 2, 3, same. 1, 2, 3, right? 3 unknown. Can we solve? Sure we can, because we have 3 equations. We can solve 3 unknown, right? 3 equations is what? Summation of fx, summation of fy, and summation of moment. Right, so what's the easiest way? Moment about this point is the easiest, right? So normally we go take the moment at point where you have 2 unknown, right? So it cancel. So you can say summation of moment about point, this is point B, right? About point B, at that point, let's consider counterclockwise, equal to 0. So we will have, okay, what is the length? Okay, sorry, this is the length here is 3 meter. So my free body diagram is not completed yet just now. So this is 3m and 4m. Right, so if we take NA there, so the distance will be 3, right? So NA times 3 meter. And then this 0.25 NA also counterclockwise, so the distance will be 4, so plus 0.25 NA, distance of 4. And then this one, it's clockwise, so minus 20 times 9.81 times the distance of this should be halfway, so this is 2, and then you have equal to 0. From here you should be able to solve for NA, right? So if you calculate this, if the calculation is correct, you get NA equal to 98.1 Newton. Right. So, okay, what is the question again? The question is asking about what is the minimum P, right? So I don't really care about this one. So I can straight away solve for P, right? So summation of fx equal to 0. If I take positive to the right, so you have P. Oh, this is too easy. So P minus 98.1 equal to 0. So P equal to 98.1 Newton. That is my answer. So yeah, the solution is quite straightforward and easy actually. But if you do not understand how to get the correct free body diagram in the first place, if you don't understand why the friction is going up, is it maximum, etc. So something that is as simple can be, you can make mistake and get it wrong, right? So that's the question, part A, right? What is the minimum force P to prevent it from sliding down? Okay, so hopefully understood. What about the part B question? Sorry, if the contact surface B is not smooth, here is not smooth, will the minimum force P necessarily be higher or lower, and why? Can you answer it? So anything that goes in the line that of, I'm going from the reasoning first, right? If this is not smooth, what will you have? You will have friction there, right? That prevent it from, that will try to counter the possible movement as well, right? So it tend to slide down, so this friction counter, this friction is also counter, right? So if this also counter, the requirement for this one will be less, right? Because it is not the lone force countering the movement, right? So the necessary force P in that situation to prevent from sliding is lower, right? So anything along that line, if you can reason that, give the reason why, you'll get the marks for part B. Alright, so that's the first question. This is the easiest question because there's no two possibilities here. It's straight away how to prevent the sliding. Alright, so moving on to the question number 2. Okay, to question number 2. So we have 2 blocks there in the diagram, block A and block B. The question says, refer to the figure for the question, referring to the friction coefficient of the blocks as shown in the figure. So as you refer to the figure, you will see that you have coefficient between block A and the ground, mu A equal to 0.1, and then between block A and block B, mu AB is 0.3, right? So referring to the friction coefficient of the blocks, what are the 3 possibilities that can happen if force P is large enough to cause a motion? Right, so this question is straightway asking your understanding, right? What basically the question already specified there are 3 possibilities. So what are the 3? Question B, block A and B have a mass of 10 kg and 8 kg respectively. Using the coefficient of static friction indicated, determine the largest force P which can be applied to the cord without causing motion. There are pulleys at C and D, and hint, you can compare the force P corresponding to each possibilities. Part C, if you can change 2 coefficients of static friction or the dimension of the block B, how will you change them so that the other possibility that can occur when force P is large enough to cause a motion from your answer for part A are to take place? Okay, the way the question might be long and complicated, but it means that how will you change the coefficient of friction as well as the dimension of block B in order for the other possibility to happen, right? So if we have answer part A, we have specified 3 possibilities, right? What are the possibilities we will discuss. And part B we have actually solved, and we will determine which possibility will actually happen or occur. And then part C, the question says how will you change the parameters so that the other 2 possibilities can happen, right? So that's basically the question, right? So part A, just looking at the diagram, can you specify what are the 3 possibilities, right? So so there's one straight way you can see is, one possibility is the block B will slip first, meaning that it will move, right? Block B will move according to the cable that is pulling, right? Second possibility, block B will tip, right? So the first one that we mentioned is slip first, and the second one is tip first, right? Okay, the tipping is on the left, right? So which direction am I showing? Okay, and then the other possibility is B and A will move together, right? Meaning that between B and A they will stuck, and then the movement will be together with block A and B, right? So that is the 3 possibilities, right? Hopefully you can imagine that from the beginning, and this question is already specified. There are 3 possibilities from the beginning, right? To help you out, because sometimes the third possibilities might not occur for some students, so the question already specified there are 3. Okay, so that is the thing. So if we consider, because part B we have to solve, and then the question already gives you a hint, right? So if you solve using the 3 scenarios, each scenario will give you one answer for force P, because the question is what? what is the largest, determine the largest force P that can be applied without causing a motion, right? So meaning that the maximum force before it moves, meaning impending motion, right? So okay, so first possibility is block B slip first, right? Second possibility is block B tip first. Possibility number 3 is blocks A and B, A and B slip or move together, right? It's actually before the movement. So basically, but also here is understood, right? Before tipping and before slipping, right? So basically slip, yeah, I think you understand what it means, right? So that it will slip between block A and the floor. So each of these will have its own free body diagram, right? Now, if the block B will slip first, then when you draw the free body diagram, this is block B. So where will be the normal force? That's the one. Okay, one thing that is obvious is the force P is there, right? And we want to find the value for force P, and then the weight is there, and the weight is given, right? This is what we're answering part B, right? So the weight in part B, it says, right, block A have 10 kilogram, block B have 8 kilogram. So here we are drawing block B. So 8, where to write this? 8 times 9.81 Newton, right? So where is the direction of the friction? It should be to the left, right? Because the movement, the tendency for movement due to this force is to the right, right? So friction will on this side. So friction, and when we say slip first, then friction, this one is F max, right? So meaning that this one is already F max, which means mu S n. So mu S is 0.3, and then n. This is n. Let's label this MB, and then we have NB. Not yet at the tip, but somewhere towards that. Okay, one question. When we have P here, NB will move to the right or to the left? Because okay, when we draw this, okay, we have the dimension, right? So this one is 300 mm, this one is 400 mm. Now, my question will be valid because when we do block B tip first, right? So P is the same. This one 8 times 9.81 Newton is the same. Okay, friction will be different because friction will be this is not maximum, because when we say tip first, meaning that it tip before friction reach the maximum. NB have to be a tip at the edge, right? So which edge? On the right or on the left? So that's my question, because if it's moved to the right, then it will already reach the edge here. If it's moved to the left, it will reach the edge here. And the way you draw will influence how you calculate, because taking the moment, you have to calculate something, right? Yeah. So hopefully it's clear which direction it will go, right? Because this force, right, the force there will try to take me there, right? So the normal reaction beginning at the center, down there at the center, right, it will move to this direction to counter the moment there, right? So hopefully you can imagine that thing, right? Because this force is pulling this direction, producing moment in this way. So the normal reaction we move to counter the moment back. So that equation summation of moment equal to 0, right? So if it's push, N will go here, right, to counter the moment. If it's pulled that way, it will counter the moment as such, right? So this is known, 300, 400, and of course this is known, right? This X we do not know, right? This one is of course at the edge. What about block A and B move together? So it will be together like this, right? So the friction will be here, F max, right? Well, this one is different. This F max is using mu as AB 0.3. This one will be 0.1 and E, for example. So you have an A, for example, right? And then you have P here, and then you have this is 8 times 9.81. This one is 10, right? 10 times 9.81. Okay, I think I should use the different color because it's confusing there. Okay, so after you have established, because this hopefully it's clear, right? Different assumption lead to different free body diagram. Obviously different free body diagram lead to different calculation and answer, right? So if we start here and we just okay, there are two ways of doing this, right? One is you assume one of these things and then you check whether the assumption is correct or not. Another one, you calculate P for everything and then you see whether it is correct, right? So because the question actually hint you can compare the force corresponding to each possibility, so we can just compare all the P, right? So in this case, okay, do we have enough space? Okay, I'll use here, right? So in this case, if you do summation of Fy equal to 0, should I use a different color? Then I have NB, is it worse? Can you still see? Minus 8 times 9.81 equal to 0, right? Is it clear? Which color is better? Maybe I should find a better marker, right? Okay, so NB will be what? 78.48, right? So NB becomes 78.48 Newton. Okay, this one is also at the end of its life. So, okay. So, if you have known that already, if you do summation of Fx equal to 0, then if you say P minus 0.3 times NB, which is 78.48 equal to 0, so P you can calculate and that should equal to 23.544. 23.544 Newton. Okay, I hope you can still see all these writings, right? Because the color is becoming, I should get new marker. Okay, so that gives you P. What about this one? In this case, you do not know F, right? So, what you know is this position NB here, right? So, one way is we take, if you want to take moment, you have to specify what point is that. I'll say this is point O. Let's say, I'll say that's point O. So, I can say summation of moment about point O equal to 0. Why I choose this one? Because I want to cancel this and this, right? Because at this point, this and this doesn't produce any moment. So, I can calculate P straight away. So, if I take clockwise as positive, P times distance of 400 and then minus 8 times 9.81 times the distance of 150 equal to 0. Then you can calculate P straight away, right? So if you calculate this, you should get 29.43 Newton. Okay, so far, before we go here, right? What can you conclude between these two? Because when you say, I assume B slip first, you get 23.544 Newton. I assume tip first, I get 29.43 Newton. Meaning what? Meaning that when you reach 23.5 Newton, this already slip. Meaning this one will not be happening because before it reached 29, it reached 23 first. Meaning this will occur first and this will never become a reality, right? Because it's already moving. But we do not know yet whether this is the first thing to happen, because we have to check this one as well, right? So in this case, if you do summation of Fy equal to 0, you get NA and then minus 8 times 9.81 and then minus 10 times 9.81 equal to 0. And then from here you can get NA equal to, alright, so I think really, and hit another marker, 176.58 Newton. Everything in Newton, right? So based on that, if you do summation of Fx equal to 0 here, get P minus 0.176.58 Newton. That's all, is it? Equal to 0. Then P equal to 17.6. This is 0.1, right? Yeah. 17.658 Newton. Can you see down there? Okay. Meaning what? Meaning which one happened first from this comparison? Right? So meaning that this one will reach first, right? Because when you increase P until 17.6, this already occurs. So it will never reach 23, it will never reach 29. So based on the comparison, this is, so you have to actually explain in the paper, because this one I'm verbally explaining. So in the paper you'll have to say, so minimum or the smallest P for the three possibilities is 17.658 Newton. So this is the answer. So A and B slips together, right? So that is your answer for part B, right? So meaning that this is what will happen first. When it says, when we say happen first, it doesn't mean this happened and then that happened and that happened, because when this happened, then it's already moving. So you are no longer talking about statics, you are talking about dynamics. So that's next semester, inshallah. So it's outside of our realm already, right? So yeah, what happened next semester, inshallah, right? Okay, so that's the answer for part B. Now, part C. If you can change the two coefficients, so if you look back at the diagram, if you can change mu AB and mu A, also you can change the dimension of the block B. Okay, before we go there, I'm not sure whether someone will ask, why not they both tip together? Is it possible? By the dimension, by the geometry, it's not possible, right? How can B pull A to tip together? It's not physically possible, right? Another hint in terms of if only one block, right? One block. If the drawing is like, the block is like it have a big width and not so tall, normally we don't even consider tipping because it's not possible physically, right? Okay, my wire. Okay. And another hint is here is that the dimension for block A is not even given, right? The dimension of B only given. Because why? Because we only need to calculate moment here, so it will give you dimension. So when the block is not even being given any dimension, it means it will never topple. It means you don't even need to calculate the moment. All right. Going back to part C, if you can change two coefficients meaning the two coefficient and as well as the dimension, what will you do to make the other possibility to occur? So right now we know already this one will happen. Oh, this one, right? A and B will move together, meaning that it will slip here at the bottom. Okay, so first, how to avoid this one from happening and make sure this one happen, so that it will not slip here, it will slip here, meaning that this one will slip first, right? Meaning block B will move first and then this one will still be, right? The thing is, if you notice, this coefficient of friction is very small, right? 0.1, which means that despite the heavy weight here, this one will not, the maximum friction will be still very small. So if we want to change that, we do not want this to move together, we want this to move together. So this mu, you can suggest, this is one of the suggestion, right? Mu A need to be higher, so that the friction here will be large, that this friction, this maximum friction will reach first. Meaning that you can also say lower mu AB from 0.3 to, of course this question doesn't ask you to actually calculate, right? Because it will too much time if you want to calculate what's the coefficient that will enable that. But this is just asking theoretically, so you just answer theoretically, right? Minimum coefficient here, maximum coefficient here, then you can change to B slip first. But how to make this one then? Because if you change that, then you actually, if you increase this, you will prevent this from slipping. Then this will slip first, right? Because you can see this one is smaller than this one, right? So if it doesn't slip here, it may slip here, right? If this one is bigger. How to make this happen then? To prevent this? One way, because there's many ways. One way is, because the concept is NB needs to reach the tip first, the edge first before maximum friction takes place, right? So one way is you make this higher or make this lower, for example, right? So it becomes very thin and tall, for example. These are all because there's no one answer for this kind of question. As long as it's logical and you can restate why, then you get the marks, right? So this is just one logical answer that you can say, okay? So you make this high and this small, then this will reach that one first and then it will topple, right? So logically, if you, it becomes very thin like this, it's easily topple first, right? So for example, okay, so that's the question number 2. Hopefully you understand. Hopefully you understand, and we'll go to question number 3. Okay, this is the question number 3. So we have a picture there where a person is pulling a rope or a cable, and the cable goes through the pulleys, and we have the box or crate there on the ground, right? So refer to the figure for this question. Part A, determine the smallest force the man must exert on the rope in order to move the 90 kilogram crate. Also, what is the angle theta at this moment? The coefficient of static friction between the crate and the floor is mu s equal to 0.2. Part B, if the mass of the crate is 80 kilogram and the smallest force required for the man to exert on the rope to move the crate is 452 Newton, what is the coefficient of static friction between the crate and the plane is mu s. Also, what is the angle theta at this moment? So the sentence there is quite weird, but basically the question asks for mu s, right? And then part C, based on all the angles shown in the figure, can the angle theta be 0? Why or why not? Alright, so based on this question, we have two parts in terms of the calculation part, and the part C is basically conceptual understanding part, I think. Right, so basically we will have to deal with the pulley as well as the box and the friction there, right? So this is where the friction problem combined with equilibrium of pulley or point, right? Okay, so let's take a look at question A first, right? So it says determine the smallest force that the man must exert in order to move the crate, right? Meaning that this is a case of impending motion, right? What is the smallest force to move? Meaning that when it reaches that force, it is about to move, right? So that is impending motion problem. So based on that, we know that the friction on the ground between the box on the ground must be the maximum, which is mu s n, right? Okay, so we will have to draw both free body diagram because this is combination of those understanding, right? So part A, so we'll have, if I'm drawing the pulley first, so basically if you draw the pulley here, so we have a force that makes 30 degrees here, and then the force that makes 40 degrees here, 45 degrees, sorry, and then the force that is making an angle theta there, right? So let's label this. One thing for sure is we know that this and this the same tension, right? The same force because the same cable, right? And that cable goes to the man. So let's call that force from the man, right? Fm. And then let's call this we call this tension maybe. So let's call that T. Right? So this is the free body diagram of the pulley. And we have to also draw the free body diagram of the crate, right? So it is basically just T there, the corresponding T, and then we have the angle theta there. And then we have the weight, right? 90 kilograms. So we have 90 times 9.81 Newton going down. And because the force is towards the left, the tendency for movement is towards the left, so friction will be towards the right. So, and we know it is equal to mu s n as we've discussed just now, so it is 0.2, and let's call it m box, right? Even though the question says crate, right? So we have a normal force there, so n b, right? Alright, so we have both free body diagram. Now, there's a question here actually, right? When you have force like this, isn't there two possibilities, either tip first or slip first, right? But in any question, as we mentioned before, when the box or the object, the dimension is not even given, then it's assumed it's safe to assume that tipping is not even in the radar. Tipping is not even a possibility, right? Otherwise, we will have to calculate moment, and when they give a dimension of the box, then you have to calculate that. You have to consider that. Otherwise, it is assumed that it will not happen, right? Okay. So between these two, we have how many unknown here? We have Fm is one unknown, T is the second unknown, theta is 3, and B is 4. So 4 unknown. How many equations do we have? Here we only have 2 equations, Fx and Fy. Here as well 2 equations, because there's no moment. Moment is not useful here, right? Because we cannot calculate any moment without distance, without dimensions. Hence we have 2 equations. 2 equations become 4 equations, and 4 unknown we should be able to solve, right? 4 equations and 4 unknown, right? So where to start? Because here we have 3 unknown, 1, 2, 3. Here we also have 3 unknown. So simultaneous equation will come into the picture, right? Because we cannot straight away solve in any of these, right? So let's put the equation of equilibrium for this one part first, right? Okay, summation of fx equal to 0. Then taken to the right as positive, so let's take this one first. So t sine theta plus fm cos 45 degrees minus Fm cos 30 degrees equal to 0. Right, so here I think we can rearrange, right? So T sine theta equal to, this can be calculated, right? So if you use the calculator, I think the number will be something like, what is the number? 0.1589 Fm, right? So do verify all these numbers, right? Summation of Fy equal to 0. Then we'll have, if I'm taking this one first, okay, Fy, okay, Fm sine 45 degrees plus Fm sine 30 degrees minus T cos theta equal to 0. If we bring this on the other side, so we can rearrange the T cos theta equal to, you get something here, you add them, the number should be 1.2071 Fm. We have two equations, right? Can we solve this? Well, we can cancel each other, right? Either we substitute T into this one, right? So there are several ways of doing this simultaneous equation. You can use whichever one you are familiar with, right? One example is 1 divided by 2, right? Meaning this equation divided by this equation. So 2 sin theta divided by T cos theta, T cancel, but we get tangent theta, right? Sin theta over cos theta become tangent theta, and 0.1589 Fm divided by 1.2071 Fm. Of course, Fm cancel each other, so the number will be 0.13164. 0.13164. Okay, so based on this, theta is 7.5 degrees, 7.50 degrees, right? So again, what is the question one? I didn't. Okay, the best practice, as I mentioned before in many tutorial, that you in exam you should write what the question one in the end, so that you do not forget, right? So in this case, what we want to have Fm basically. What is the smallest force from the main? So Fm, and we also want theta, right? Okay, so then theta is found already, right? Where should we calculate further? I use on top there. All right. So right now we have theta already. So if we replace, can we do anything? We can get Fm, right? Wait, do we need to solve this one? What is the question again? Because if you put theta here and here, then you have T and, oh no, yeah, you have T and Fm, right? But you have to know one of those, right? So okay, so if you do summation of equation here, summation of equation of equilibrium, right? So what am I doing? Okay, simultaneous equation again, right? Summation of fx equal to 0. So basically you'll have 0.2 and b minus t sine theta. Okay, theta we already have the value, right? So theta is 7.5 degrees equal to 0. Right? And then we have summation of fy, equal to 0. Then we have t cos 7.5 degrees plus and b minus 90 times 9.81 equal to 0. Right, so we have to equation n to unknown, right. So based on this, actually I'm skipping steps here because you can try on your own the simultaneous equation. But if the calculation is correct, if my calculation is correct, then T here will be 537 Newton. So after you have, because here from the simultaneous equation you can solve for NB and T, right? So but we are interested in T because we want to plug in here, right? So based on that, if I plug in T here, 537.04 multiplied by sine theta sine 7.5 and then divide by 0.1589, you get 441. So Fm you get 441.14 Newton, right? So just to verify, it's good to verify if you did any mistake. So if you plug in here, so T is 537.04 multiplied by cos 7.5 degrees and then divide by 1.2071, 441.09. Okay, so there will be decimal point error there, but basically it's 441 Newton, right? So there you go. This is an example of a friction problem that is combined with a pulley, right? So you have simultaneous equation here and there, right? So we'll move on to part B, right? So this is part A, where what is given is the weight of the mass of the crate is given, and the coefficient is given, right? So part B, the question is flipped, where force is given and force is given, then mu s is not given, right? Theta is still not given. Alright, so for part B, then because the free body diagram is fundamentally the same except the values that we may have, right? So here, so mu s is not given, so mu s and b, like that, right? So mu s is not given, theta is still not given, but here we already given 452 Newton, 452 Newton, right? So because the of course in the exam you cannot do like this, right? In the exam you have to start fresh, right? Part B, all right, draw the free body diagram yet again, and then you cannot because you cannot have one free body diagram for different question unless it's continuation question, right? Here the case is totally changed. So one question is FM, one question is 452. You cannot mix that up, right? So all right, so given that, so what will happen is just FM will change to 452, right? Similarly here, right? So essentially nothing really changed, because here 452, nothing really changed. Something changed, the value changed, but the calculation step is a bonus, because this one, okay, if you didn't multiply, right, it's meaning if you put in bracket like this, so 452, right, in the place of force just now. So similarly here, 452, 452, right? So you'll have a bracket here, 452, right? So if you do the same, meaning equation 1 divide by equation 2, because t cancel with t, sine divided by cos become tangent, this value divided by this value, you get this value, this and this you divide, it cancel each other, so you get this back again, right? So this is basically a constant based on this, right? Based on this scenario, theta will still be this one, even though tension, this is different, right? Before we get 441 just now, right? But now we have 452. Not much different, but it's a different value. But still, with this with that free body diagram, it's going to be the same. All right, so going here, so of course we do not know mu s, and okay, we'll start fresh here, right? Just to not get confused. So if you do, right now we already have theta. Okay, if we have theta, in this case, we can plug in here and we can actually calculate t, right? So t is, what is calculation? 550.32. 550.32 Newton. So okay, the question wants theta and also mu s, right? So given this known, so this t is now we know already 550.32. So when you do summation of fx equal to 0, so this one become mu s and b, and then minus t is actually 550.32, 550.32, and then sine theta. Sine theta is already known, 7.5 degrees. Right. So actually, okay, sorry, equal to 0. Okay, we still have simultaneous question, right? Because we have two unknown. And then summation of fy, is it? Okay, this one we should be straight away solved, right? T is 550.32 cos 7.5 degrees, and then minus a plus and b minus 90 times 9.81 equal to 0. Then from here you should be able to solve what is NB, and NB will be 239.2 Newton. So you can plug in there, you should be able to solve mu s equal to 0.3. Right? So yeah, so that's basically, I'm not sure whether to consider it as a bonus or something, but because both A and B have basically similar free body diagram and equation, right? It's just that the number changes, right? Of course, in the exam you have to repeat and do the whole thing again, but because if you know how to do one, you should know how to do the other, right? Okay, based on part C now, based on all angle shown in the figure, so the figure still maintain, meaning that you have the 30 degrees and 45 degrees, right? Can angle theta be 0? Why or why not? Alright, so interestingly, because if you have noticed, this never change, that already a sign, right? But okay, can or cannot, right? So mathematically, because the free body diagram is concrete like this, right? Can this theta be 0? If just by looking at this, can or not? It cannot, right? Physically impossible, mathematically impossible as well, right? So because if you look at this, right, because this is summation of fx, right? For example, if you take in summation of fx, then this equation will hold regardless, right? Regardless of whatever value here, whatever value there, it will be something like this, right? Can this be 0? Can this theta be 0? Because if theta can be 0, it's not logical, right? Because sine 0 is 0. 0 times 0 is 0. 0 cannot be some value there, right? Unless the man is not pulling, right? Then there's no tension, and well, then the whole thing just fall down, right? So that's not logical as well. So basically it's not possible. This theta is not possible to be 0, right, under these circumstances. Alright, so any way that you can logically answer that, either by showing the a sentence or showing the equation to show that it's impossible to get 0, you'll get the marks for that one. Alright, so that is question number 3. We'll move on to question number 4. Okay, for this question, you have the diagram there where you have a box basically on a surface that is slanted at a 30 degrees angle there, and you have a force P there, a horizontal force P, right? And then you have 3 parts of the question. Part A, determine the minimum force P required to push the crate up the plane as shown in the figure. The crate has a mass of 60 kg and the coefficient of static friction between the crate and the plane is μs equal to 0.25. Part B, determine the minimum force P required to hold the crate from sliding down the plane as shown in the figure. The crate has a mass of 60 kg and the coefficient of static friction between the crate and the plane is μs equal to 0.25. And part C, given the crate is on the surface 30 degrees from the horizontal as shown in the figure, what condition is required for the crate to be held in place, meaning not sliding down, if no external force P is applied or P equal to 0? Why? Alright, so 2 questions that you have to do the calculation, and part C is basically conceptual understanding. Right, so in part A and B, basically the diagram is the same, the force is the same, the angle is the same, the mass is the same, the coefficient of static friction is also the same, 0.25. The only difference is that question A asks what is the minimum force to push it up, while part B, what is the minimum force not to allow it to fall down or to slide down, right? So that is where the free body diagram will be different, because the friction is on the different direction, right? So if you go to part A first, if you go to part A, basically the crate, if you draw the free body diagram, it will be like that, and we have force P there. The weight will be down 60 kg, right? 60 times 9.81 Newton there, going down, vertically down. So with that, because we have the angle of 30 degrees here, right? 30 degrees, meaning that this is 30 degrees there. And then obviously we'll have some normal force there, let's say NB for box, and then the friction. Okay, the first question is, what is the minimum force P required to push up? So if to push the crate up, meaning the movement, the tendency for movement is going up, so the friction is resisting that movement, so it is going down. And because it's impending motion, so it is equal to μsn, so 0.25 NB. Right, so that will be your free body diagram for part A. Right, so how many unknown do we have? P and NB. Only 2? Okay, so this is quite straightforward, right? Because the dimension is not given. That's a hint of there's no possibility of tipping. So you will only have summation of fx and summation of fy, right? Okay, so all right, so because basically this is 30 degrees as well, right? So if you go there, so we just have to do summation of fx and summation of fy. Summation of fx equal to 0, for example. So you'll have p minus, let's do this one first, minus 0.25 and b cos 30 degrees, and then minus and b sine 30 degrees equal to 0. Right, from here you should be able to see, for example, P equal to something NB, right? What is my answer here? Okay, if this summation of Fy, let's say summation of Fy equal to 0, then you'll have, okay, here you can get the number straight away, right? So you should do this one first if you want straight answer, right? So if you do this one, so you'll have, this one will be NB cos 30 degrees, and but this one vertical component, so minus and minus 0.25 NB, 0.25 NB sine 50 degrees minus 60 times 9.81 equal to 0. So from here NB equal to 794.33 Newton. Oh yeah, just a reminder, because in the lecture I did mention, but why we have always a habit of naming it N something, NB, NM, etc. Because to avoid confusion with Newton, right? Otherwise it's N equal to this one N, so it's confusing. Anyway, so and here you can plug in there, so you can calculate this. I'm jumping steps right now, right? So you can, in the exam you have to show properly. So 569.14 Newton, or basically 569 Newton, right? So that will be the answer for this one. Okay, straightforward, right? Now, what will happen if we go to part B? Part B, it says, determine the minimum force P required to hold the crate from sliding down. Other parameters is the same. So meaning the only difference is that the movement, the tendency for movement is going down, so the friction will be upwards, right? In that case, what will be different is this one, right? So this one become plus because it's to the right, and this one will become plus as well because it's upward, right? Because the rest is the same. So when you do summation of fx and y, it's the same, right? But of course the value here will be different. So from this calculation, and we'll get 593.95 Newton, and then based on that, P equal to 168.38 or 168 Newton. That's the final answer, right? Again, in the exam or on paper, you should properly do all the steps again, right? Because the marks is in the steps actually, right, in the exam. So you have to show that even though, because the scenario is different, it can be different, but most of the thing is the same. So just be happy that it's easy to solve both questions once you know, when you understand one, right? All right, part C. Given the crate is on the surface like that, 30 degrees, so meaning that we cannot change the angle, what condition is required for the crate to be in place, not moving down, not falling down, if we do not have P? This is conceptual, this is simple, right? The only parameters that we can change is what? We can make the surface more rough, right? Or in technical terms, increase or make the mu s greater until the friction is great enough that the box will just cannot move down, right? So anything that you mention along that line will be rewarded with the marks, right? All right, so moving on to the next question. Okay, the next question. So we have the block there. There's a rope tied to it and go to the weight there at D, right? So it says block A in the figure has a mass of 50 kilogram and rest on a surface for which mu s equal to 0.25. if the bag at C is smooth, meaning no friction there at C, determine the greatest mass of the suspended cylinder D without causing motion. Clearly state any assumption that you make, if there is any. Sorry. Okay. So basically, you can see that the block A have dimensions, right? Meaning that you have to consider the moment, right? So that's a hint already. And of course, the question already hint again, clearly state any assumption, meaning that you have to assume something here, right? So how many assumptions do we have? Basically, you have, it can be either tipping or slipping first, right? So basically, we'll just go straight to the two assumptions, right? So if you assume slip first, then what you are assuming is that the normal reaction is still not reaching the edge, but the friction force already reached the maximum friction force, which is mu Sn, right? If you are assuming tip first, meaning you are assuming that the normal reaction already reached the edge and hence you want to tip over, while the friction is still below the maximum friction force, which is below mu Sn, which is an unknown number that we do not know, but it is not mu Sn, right? So the free body diagram will be different, right? So if you assume slip first, okay, so basically you have a force there, which is the force that we want to find, right? So let's call that Fd, for example, right? Because it is from the cylinder D, which is what we want to find, right? What is the greatest mass at D, right? So we should write somewhere about what we want, right? So mass MD, right? What we want. Okay, so there, and then you have the 3, 4, 5 angle, right? And then you have the dimension there, of course. So you have 50 kilograms, so 50 times 9.81 Newton. The normal reaction, it is still not to the edge, somewhere there, and B, for example. And then friction to the right, it is the maximum, which is mu Sn, which is 0.25, and B there, 0.25 and B, right? So the free body diagram will look like that, of course, with all the dimensions, right? So we'll have what is important here, so 0.3 meter here, right? What else? Of course, the half distance here is 0.125 meter, right? Half a distance. If we want to take moment there. What else? Of course, this distance is unknown, right? So this distance is x, it is unknown. Alright, so that's the free body diagram if you assume slip first. If you assume tip first, what will happen is just N is already reached the edge, right? Normal of the box before the friction reach the maximum. So this is unknown friction, and the rest is the same, right? So this one is 59.81 Newton. Oops. And you have Fd 3, 4, 5, right? And then the dimension as well. So in this case, 0.3 meter. In this case, you know exactly this distance, right? So this is 0.125 meter. Okay. So these are two different assumptions. So there are several ways that we can solve this one, right? So one, we assume one, and then we solve, and then we check for whether the assumption is correct or not, right? Second, if you do both, and then you check which FD will be smaller, and that will happen first, right? Okay, so let's take a look at this one first, right? So if you took if you, because we will have to have simultaneous equation regardless, right? So for example, summation of fx equal to 0 here, so you will have, if I take from here, minus f d 4 over 5 x, only this one and this one, so plus 0.25 and b equal to 0, right? So I haven't calculated this question yet, so I have to calculate on the spot if I want to calculate. So let's just give it a try. So f d equal to basically 0.25. Hopefully I do not make a mistake while being sleepy right now. Multiply by 5, divide by 4, you get 0.3125 and b, right? So just to calculate, 0.25 divided by 4 times 5, 0.3125 and b. Alright, so if you do summation of fz, okay, this is a sign that I'm sleepy already. So it's okay, this watch is wrong, it's 1 hour late. I need to change the battery. So summation of fy equal to 0. So we'll have fd 3 over 5 and then plus nb, this one, and minus 59.81 equal to 0, right? Okay, so this one you can plug in this case, so it will be like, if you plug in here, wait, what's the answer just now? It's 5 over 16, right? Anyway, we'll just use that one. So 0.3125 and b times 3 over 5 plus and b equal to 50 times 9.81, right? So if you add this, so 0.3125 multiplied by 3 divided by 5, you get 3 over 16 plus 1, you get 19 over 16. So 19 over 16 and b equal to 50 times 9.81, 490.5. So and b, if you calculate this one, 490.5 multiply by 16 divided by 19, you get 413.05 Newton. Then this one, you go to this one. So of course, okay, I'll because in actual you have to properly have a proper flow, right? But here I'll just calculate here, right? fd equal to 0.3125 multiplied by 413.05, so you'll get 129.08 Newton, right? Okay, that is what we have calculated here. So I will, now there's a way to check, right? So if you take moment about point here, you can calculate for x and you check whether x is still within range or it's already outside. If it's still within range, then assumption is correct. If it's already outside, the calculation is the assumption is wrong, right? But I will try to do this one first, meaning that we'll check both assumption, right? So if you do that, so in this case, if you do summation of fx equal to 0, then you'll have minus f d 4 over 5, this is still the same, and then plus f equal to 0. So f is something that unknown, right? So in this case you can, okay, so f d equal to 5 over 4 f, right? F is friction. Okay, and then you do summation of f y equal to 0, then you get f d 3 over 5 plus and b. Okay, do we have enough unknown here. You have to solve first, right? Yeah, in this case you have to use moment. Anyway, this one plus this one minus 59.81 equal to 0. Right? So even if I exchange this one, I cannot solve yet because there's two unknown left. Right? So we have to do something. So I'll take moment about point, let's say I put here point A. Let's just use A then. There's no A is the box already. Let's use O. Alright. So summation of moment about point O is 0. So F is 0, N is 0, doesn't have. So this one, vertical one is 0 as well. So horizontal, so if I take counterclockwise is positive. So horizontal is FD 3 over 5. That's the horizontal, 4 over 5 is the horizontal component. And then the distance is 0.3 meter, right? That one. And then this one is minus 99.81, and then the distance is 0.125 equal to 0. Is this getting into the light already? Okay, hopefully you can still see something, or you can do yourself as well, right? So in this case you can get in this case you can get FD straight away without having to calculate this one, right? So that's more times 9.81 times 0.125 divide by 0.3 divide by 4 multiplied by 5, you get FD equal to 459.8 Newton. Right, verify the answer. Okay, so if that is the case, then this will happen first, right? From there you can conclude, what is the question? What is the mass MD, right? So this is the weight, the force, which is the weight. So mass is, so MD equal to 129.08 divided by 9.81, you get something in terms of kilogram. You can calculate that one, right? So this is if you do want to compare, meaning you want to calculate both assumption and then you compare, right? If, for example, you have assumed this one first and you do not want to continue there, you just want to check for X. So what do? Is you take moment, for example, I call it O, in case you haven't done that one, right? So normally we cannot label this O and that O at the same time, right? So if we have both assumption, then this should not be both O. But if we assume that we haven't done this yet, we are just only check until here, and I want to see whether this is correct or not. So if I take moment about point O, okay, so if where to write? So if I put here, right? But NB I want to use, so okay. So if you do summation of moment about point O equal to 0, let's say counterclockwise is positive. So what you have is this one. Okay, there's a lot to calculate then. Okay, FD. So FD is this one, right? So if I put straight away 129.08 4 over 5, this counter, so 0.3. Okay, and then the upwards is become negative, so negative 129.08 3 over 5. That's vertical, that is clockwise, so times X. That is the unknown distance there. And then this is 0, this is 0. Okay. This doesn't produce moment, this doesn't produce moment. So okay, 0 equal to 0, right? So what will X be? So in this case, wait. NB is still there, right? So what am I doing? This is a proof that I'm already sleepy and my mind is shutting down. Okay, so again, this one is horizontal clockwise, this one is vertical, this is counterclockwise, sorry, this is clockwise, and NB plus minus NB already here. Okay, so sorry. So 413.05 times distance of, wait, what is this? Okay. Astaghfirullahalazim. I'm so sleepy already. Okay. Again, repeat. So, if you reach this point, and of course you have calculated NB also, I have erased this part, and you do not want to check with the second assumption, you just want to check here only, right? So how you check is to calculate X. So what you can do, you can take moment about this point O here. Summation of moment about point O equal to 0. Okay, so this one, the horizontal, if you take counterclockwise positive, that will be positive. So FD, which is 129.08, and then 4/5, that's the horizontal, and then the distance is 0.3. Alright, and then the vertical, so it's clockwise, so minus 129.08, 3/5, and then the distance is 0.125, and then NB counterclockwise as well, NB times the distance of NB is already known, so the value is there, minus 413.05 times the distance of X equal to 0. Right, so what will this be? So if I calculate this one, 129.08 multiplied by 4 divided by 5 multiplied by 0.3, you get a number, and then minus this one, minus 129.08 multiplied by 3 divided by 5 multiplied by 0.125, you get 21.29, okay, something, and then this bring there, so this divide by 413.05, X will get 0.052 meter. So 0.052 is less than 0.125. So assumption correct. So FD is this one. So M is that one, right? So if you do this checking, you have to show a way of checking properly. So you do this calculation, and then you have to say the conclusion, right? Okay, this is equal to this one. Even if you in your mind, this is correct, but you have to show on paper, because otherwise we do not know whether you stop there without any valid reason or what. So it means that it is less than this whole width, so meaning the assumption is correct. By that, what is the answer then? Then this is correct, and then you calculate, right? So that's the way you check. If you only do this one, how to check? You check F, right? So we haven't calculated F, right? Because if you have calculated FD, you can plug in here, you can calculate for F, and then F, if you calculate, if you compare with, alright, let's do, right? If you start here, and then you have calculated FD, so FD you plug in here, then F you can calculate by, okay, but still you have to have NB. Okay, I'm too lazy to do this. Okay, so you can calculate this one, you can plug in here, you can calculate F, fine. But how to check? F have to check with respect with mu Sn, which is the F max. So if the calculation is correct, you can verify. If you can try, if you have the time, or if you want to try, then F here should be more than F max. Hence, assumption wrong. Right? So you have to go here. Right? So those are the possibilities in the exam. So I don't know, whichever way that you prefer to do, right? What the one check, so that's based on luck, I guess, but that's the way that I do is also possible. You just calculate force required for this to happen, force required for this to happen, which one is smaller, happen first. Alright, so that's for this question. Moving on to the next question. Okay, in this question, we have the diagram there where someone is trying to push the crate, right? So, the uniform crate shown in the figure has a mass of 160 kg. Assume the man exerts only horizontal force on the crate. Alright, so part A, if the coefficient of static friction between the crate and the floor is mu s equal to 0.2 and the smallest force by the man to move the crate need to be determined, what are the two assumptions that can be made? Draw the free body diagram corresponding to each assumption and clearly label which free body diagram is based on which assumption. Alright, part B, for each assumption determine the smallest force needed to move the crate. Part C, based on the answers obtained in part B, which assumption is the correct one? How is this being determined? Part D, determine the smallest weight of the man so he can move the crate. The coefficient of static friction between his shoes and the floor is mu s equal to 0.45. Alright, so a lot of part here, but actually in this exam, I think the lecturer want the question to be very structured like that, so that the student know how to do step by step, right? We can just straight away answer, ask what is the force? What is the question? What is the smallest force? So you have to assume, there's two assumptions, is tip or slip. First, which one happened first, and you have to do some assumption, etc., like before. But here, it is being instructed one by one, right? Okay, so going step by step, right? Okay, the question says, number one, what are the two assumptions that can be made? So the answer is assumption slip first, and also you have tip first. So that's the two assumptions. And then the question says, draw free body diagram corresponding to each. So for slip first, what does happen is we have the force from the man there. Let's call it P. And then we have the weight, right? The crate is what? 160 kilogram. So 160 kilogram. So times 9.81 Newton. And then we have the normal reaction there, not yet at the edge, so and B. And then we have the friction, which is already the maximum when it slip first. So mu is 0.2. So 0.2 and B. This is for slip first. What about tip first? So P, and then this is the same 160, 9.81 Newton, and then NB should be already at the edge. So this is when tip happen first, right? And then friction is unknown, that is not yet the maximum value, right? So this is the maximum value, F max, right? Okay, based on that, it just says, of course you have to put all the dimensions. Okay, let's put the dimensions. This is 1.6 meter, should be the same. This one is unknown, X. This one is known, 0.6 meter, right? Okay, so and then the question says part B, right? So this is the part A. What is the two assumption? What are the two assumption and the free body diagram for each? Second, based on each assumption, determine the smallest force needed to move the crate. So what is the value of P? Yeah. So in this case, if you do summation of Fy equal to 0, you get NB minus 160 times 9.81 equal to 0, right? That's the only vertical component. So you get n b equal to something. So let's give it a try. So 160 multiplied by 9.81 becomes 1569.6 Newton. And then summation of fx equal to 0. Then you have p minus 0.2n, which is this one at nb. So I'll straight we put 1569.6 equal to 0. So this one multiplied by 0.2 should be p, right? So p equal to 313.92 Newton there. Fine. Alright. What about this one? Okay, so to make things easy, so I'll take a moment about point O here, right? So summation of moment about point O equal to 0. If I take clockwise as positive, so I'll get P times 1.6, and then this one minus 160.981 equal to 0. So from here P equal to, so if you have 160 multiplied by 9.81, you get a number, and then you should divide by 1.6, you get 981 Newton. It's quite far, huh? Okay, so based on that, which one happened first? So okay, so this one first, right? So sleep first, meaning so P, the smallest P is 313.92 Newton. Alright. Part C, based on the answer in part B, which assumption is the correct one? Okay, sorry. Part B is just what is the smallest force, pushing force for each. So this is the answer, this is answer. Part C, based on this, which one which assumption is correct? So based on this, yeah, however you want to say it, this is assumption correct, right? Or in some statement, and because the question says how is this being determined, so you have to say, okay, which one is less will happen first. So based on which is less, we know which one is correct assumption. And then part D, determine the smallest weight of the man. Alright, so how are we dealing with the man now? So we have to draw the free body diagram of the man. Now we have determined this one, right? So we will have to use this one because this is what is happening. When it reaches this force by the man, the box will start to slip already, start to move, right? So if you consider the man, so how to do this? So we have the, okay, excuse the, what is this? Okay, I'm not sure why it becomes jigsaw of saw. Alright, so something like this, something like that, right? Okay, let's consider this is close by, right? So do not consider as one, as two contact point. Let's consider as one, right? So we have the reaction force from the crates, but we have this value already, right? So this is 313.92 Newton, right? And then determine the smallest weight. So weight is not known, right? So weight is what we want to find. and then there should be a normal man here, and then we have friction here, right? Friction. And but if we say what is the smallest weight, smallest weight is meaning that it happened when the friction is maximum, right? So oops, this is already mu Sn, so 0.45, 0.45 and m here, right? Okay, so how to determine W? Quite simple, right? Because okay, this one is already in the free body diagram, so we do not need this anymore, right? So summation of fx equal to 0, then we'll have 0.45 and m minus 313.92 equal to 0, and m equal to 313.92 divided by 0.45, so you'll get 697.6 Newton, right? So we do summation of Fy equal to 0 for this one, so we'll get an m, or we have the value here, 697.6 minus W equal to 0, so W is 697.6 Newton, right? So the question says what is the smallest weight. That's already the answer there, 697, right? So roughly 70 kilogram. Of course the question doesn't want mass, it wants weight, so there you go, right? So it is quite simple actually, but if you notice this, if you make a mistake in the earlier part, meaning that this value is mistake, for example, it will, you know, the error will continue on, right? So make sure you check and double check, right? Especially in the exam. Okay, to the next question. Okay, to the next question. So we have a car here, and the question goes, the vehicle shown in the figure has a mass of 2000 kilogram and center of mass at G. Determine the towing force F required to move the car if the front brakes are locked and the back wheels are free to roll. Take mu s equal to 0.3. Part B. Will the towing force F required to move the car be higher or lower or the same if the back brakes are locked instead and the front wheels are free to roll? Why? Alright, so we'll do the part A first. Right, so you have to draw the free body diagram of the car. Right, so it doesn't need to be it doesn't need to be as accurate as long as shaped like a car. And then we have F here at 30 degrees, right? Okay, there's dimensions there, right? So this distance is 0.3 meter to the ground. All right. So, and all the dimensions given there. So before that, so it have its own weight and it's at point G there, right? So there's a weight there of 2000 grams, so 2000 kilograms, so 2000 times 9.81 Newton, right? And then there should be the normal reaction, right? So we'll have normal reaction A and normal reaction B, right? Where is the friction though, right? So if you understand the question, it says the front brakes are locked, meaning that the tire cannot rotate, right? So meaning that if you try to pull the car, then it will be friction there, right? While the back wheels are free to roll, meaning that if you pull the car, it's just roll, right? So the friction does not actually restrict the movement in that case. So in this case, the front brakes are locked, so the front brake are the one resisting, right? So you'll have here, right? But the question says determine the towing force required to move, meaning that impending motion, right? So it is maximum, so it is 0.3 and A. Alright, so that will be the free body diagram. Of course, you need all the dimensions. So 0.75, so this one is, okay, this one is 0.75 meter, that is 1, and then this is 1.5 meter. Right. How many unknown? 1, 2, same, 3, right? So you should be able to solve. But still it does need simultaneous equation, right? Because if you take moment, you cannot cancel any two unknown simultaneously, right? So if you do, for example, this is point A, right? Okay, point A. So if you do summation of moment about point A equal to 0, and if you take counterclockwise as positive, so this 0, this one will have something, this one will have something, right? So F here, the horizontal one will be F cos 30, right? Horizontal one have this distance of 0.3 meter, and if you take counterclockwise, that's counterclockwise. Then the vertical one is becoming clockwise, so negative F sine 30 degrees, and the distance will be 0.75. And then here will be clockwise as well, so minus 2000 times 9.81 there, that's the force, and then distance of 1. And then you have this one, NB, so plus NB times distance of 1.5, 2.5, equal to 0. So that's the one equation that linked F with NB. Okay, how this is interesting. On second thought, I shouldn't have done this one, right? I should have done, because we have to be strategic with what equation do we, because right now I haven't been strategizing with this one, right? I just said we jump into it, right? But if you want to strategize, you can see, okay, if we do, because we will see in which axis we can have the minimum number of unknown, right? So for example, in this case, x-axis, so summation of f x equal to 0. For example, you only have minus f cos 30 degrees, and then plus 0.3 and A. This one, no, equal to 0, right? So here actually you relate f with an E, right? So what do you want to find? We want to find f, right? Okay, so NA equal to, if I have my calculator, cos 30 divide by 0.3, 2.8868 F, right? You can verify the calculation. So cos 30 divide cos 30 divide by 0.3, so it's 2.8868. all right, so if we can calculate something that relates NA to F as well, then that will be awesome, right? In terms of minimizing calculation need, right? So might as well I take moment about point B, so that I can only have NA and F yet again, right? So if I take moment about point B, okay, this will be long, is it? Okay, if I take counterclockwise, so okay, this one is not creating moment, so this one will be negative, right? Okay, I'll start with this one. F. So the horizontal one, F cos 30 degrees. The distance is 0.3. Alright. And then vertical, so minus, because it's clockwise, so minus F sine 30 degrees. The distance will be 1.5 plus 1 become 2.5 plus this one become 3.25. Is that correct? Okay, I'm sleepy already, so I need to double check. Becomes 3.25. Yeah. So moment about point B. So this one, okay, this one both included. This one, okay. So minus and A multiplied by the distance of 2.5 equal to 0, right? So and A I can replace by this. So hence you will get F only, right? So if I calculate, wait, I forgot. Okay, this is the worst thing. So do not be sleepy in your exam, otherwise you are not sharp, because you are missing big things, right? So okay, this one, horizontal and vertical. This one no, this one yes, this one, because where's the number? I cannot calculate this way, right? So this one become plus 2009.81 equal to 0. Okay, is there anything else? Done, both component. This one not related. This one done, this one done. No. Okay. So with this, right? So if you calculate this one for, because NA is this one F, right? So we can calculate F equal to something, then we can calculate, right? So let me try. Hopefully I'm not too sleepy to mess this thing up. Cos 30. So something number minus 3.25 times sine 30. Okay, is it negative? So minus, oh yeah, because then we bring that way, yeah? Minus this one is this one, right? So 2.8868 times 2.5. Then basically you get 8.5822 F equal to this whole thing, 2000 times 9.81, 19 C20. So F equal to this one divided by 8.5822 to 286.1 Newton. Right, so you can verify. Please do verify all of this. Hopefully I didn't make any mistake, but if I do, my excuse is my mind is so not sharp when I'm so sleepy like this, right? It's past the middle of the night already. Okay, so that is the force for required to move the car in that circumstances, right? Yeah. Will the towing force F required to move the car becomes higher or lower if the back brakes are locked instead? Why? So is there any change? That's the big question, right? If instead of friction there, it is here, then it will be 0.3 and B, right? Correct? So actually the friction will not be the same. Mu is the same, but friction depend on the normal reaction at that point, right? So you have to actually determine, because here I didn't calculate NA and NB, right? So you have to see the comparison between NA and B actually, right? So this one then it actually requires some if you already have calculated and you relate to F, for example, then you can see, right? Because which one is higher, which one is lower, and then because the how to say, when you do summation of fx, f is dependent on, because when this is not here, right? Because either or, right? This friction or this friction. Which one is higher will cause more higher f to move this one, right? So basically you need to know which one is higher, NA or NB, right? But logically, what do you think? Of course, it's how to say, we have to prove by calculation, right? But by to look at it, because for example, there's two factors. One is this weight is more to the front, so just based on that factor, NA will be higher than NB. But this F is a bit upward, so it tend to be lifted a bit, right? So you have to do by calculation, right? So do check which one is bigger, and then you can argue, will it be higher or lower or the same, right? With that, I think this is the final question of the night. It's night for me here. I still have to produce the full tutorial video. If you watch this, meaning that is successfully done, inshallah. So with that, now, as I mentioned in the very beginning of the video, as you can see, the question can be very varying types, right? So just like I mentioned in the very beginning, the question can be of many different types from this one, right? So you just flip through the book and you can see any other different type and have a look, and at least the minimum is just try to figure out what will I do if this question, meaning how will I solve, meaning I'm not saying what will I do is I need to repeat next semester. I'm not saying that. I'm saying that, okay, so I will draw the free body diagram. What's the assumption here? So at least you have mentally try to dissect the question, right? Oh, okay, I can see the steps. Or if you cannot see, then you have to attempt, so that if that question come, you actually have at least an idea of what is the steps need to be taken, right? Obviously, when it comes, then you still have to do the calculation, etc. But at least if you know what to do, that's half of the battle already, right? But because some students, it seems that in the exam they're totally blank. I do not know how to move forward. That's the worst case scenario. Please avoid that, because friction, if you have covered in the semester, it will be in the final, because we haven't covered it in the midterm or anything, right? So it will be in the final. So be prepared for all type of questions. That what is my point, right? I think in the question we only face one question, is it, that we have slanting angle, right? So because in the previous exam perhaps there's not many, incidentally doesn't come up that much, but due to that, if you just prepare based on this tutorial, you are not prepared enough perhaps to deal with whatever angle, etc., right? So meaning angle of the slanting the ground, right? Okay, I'm sleepy already. I need to sleep. I need to finish the video and sleep. Thank you. All the best. Seriously, I hope that you can succeed in this subject without the need of repeating, etc., right? So with that, subhanakallahumma bihamdik, ashhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Hopefully this have been helpful. I really hope it is, and see you next time, inshallah, in the next tutorial. Wallahu a'lam. Assalamu alaikum warahmatullahi wabarakatuh.